Hello everyone, welcome to Chapter 5, Chemical Quantities and Reactions. This is Section 5.6, and in Section 5.6 we're going to take some things and put them together. Everything that we've done so far in this chapter is sort of led up to this section so that we can actually look and see how we use these mole relationships in these chemical equations. In order for a chemical equation to be something that can happen, it has to obey the law of conservation of mass. And so what that basically says is that you cannot create or destroy matter. There is no change in the total mass. The mass of the products is equal to the mass of the reactants. And so basically you cannot make anything or destroy anything. You can only change its form. So you'll still have the basic building blocks that you started with. Carbon may not be in the form of glucose, it may be in the form of carbon dioxide, but an element of carbon will still be accounted for whether it's in reactants or products. And so in this particular reaction, we are reacting silver solid with sulfide, and we are forming silver sulfide. And so I should say with sulfur, we form silver sulfide. And so the mass associated with these two must equal the mass of the product that we make with those two. And so in that reactant and product, what we have are that we have 2 silver moles and 1 mole of sulfur to give us 1 mole of silver sulfide, which is Ag2S, which has 2 silvers and 1 sulfur. Okay, so 2 silver atoms and 1 silver atom gives us a formula unit of Ag2S. If we had 200 silver atoms and 100 sulfide atoms, we would have 100 Ag2S. Avogadro's number still comes into play. Moles are still 2 moles of silver, 1 mole of sulfur, give us 1 mole of silver sulfide. Now the mass also has to balance, and so if silver is 107.9, you have 2 of those plus 1 mole of sulfur, which is 32.1, that'll give us 247.9, and again 2 silvers and 1 sulfur will give us 247.9. So we have accounted for everything in our balanced equation. So in the reaction of iron and sulfur, we can now know that this number, this coefficient in front of these elements and compounds and molecules actually stands for how many moles we have, because these compounds, elements, molecules are all going to react in what are called molar ratios. Okay, that is for this reaction to occur, you're going to have 2 moles of iron, 3 moles of sulfur, and you're going to produce 1 mole of ferric sulfide. Now, if you don't have 2 moles of iron, then you can't produce 1 mole of ferric sulfide. It'll be less than that. And so this ratio can change depending on how much you have of each of these reactants. But the theoretical yield is calculated from 2 moles to 3 moles gives you 1 mole. So a 2 to 3 to 1 molar ratio. And because of that, it gives us this mole-mole factor, this ratio of how many moles of iron to how many moles of sulfur becomes a conversion. 2 moles of iron for every 3 moles of sulfur, 2 moles of iron for every 1 mole of Fe2S3, and 3 moles of sulfur for every mole of Fe2S3. And what this can allow us to do is we can calculate yields or how much it's going to take in a real chemical reaction in order for us to achieve what we want to do. So the example here in this learning check is that if you have, this is a balanced chemical equation already, we know 3 moles of hydrogen gas and 1 mole because that's understood, of nitrogen gas is going to give us 2 moles of ammonia gas. So the mole-mole factor for H2 to N2 is going to be what? Well, H2 is a 3 and N2 is a 1, so it's going to be what? It could be 3 moles of H2 to 1 mole of N2, or we know we can flip that as well. Either one will be the mole factor. The mole-mole factor for ammonia and H2, there's 2 ammonias and 3 H2s, so we have to have 2 ammonias and 3 H2s, so it would be this one. Okay, see how that works? It can be either way. It doesn't matter which one's on top or bottom, because remember, we now said that these are equivalent, or these are necessary, and so this ratio, this factor, comes in and allows us to make some calculations. So if I want to know how many moles of Fe2O3 I can get if I have 6 moles of oxygen. Now, you can probably look at that. You know that that's a 3-to-2 ratio, right? But what we're really doing is we're looking at this molar ratio. 3 moles of oxygen for every 2 moles. So if I have 6 moles instead of 3 moles, then I can multiply it by this ratio of for every, and remember, moles O2 on the bottom. Always, that's how we do this, right? When we're going to do a conversion. So 6 moles of oxygen, we use the ratio. For every 2 moles of Fe2O3, you're going to have 3 moles of oxygen. And so 6 times 2, because that's on the top, is 12, divided by 3 is 4. Yeah, you could probably have done that in your head. But if you'll try to go through the steps, if you get one that's more complicated or too complicated for you to do in your head, unless you're a savant, then it gives you practice on how to do that. So, as always, we state what is given and what we need. We write a plan to convert the given to the needed moles. We use the coefficients to write the relationships and the mole-mole factors, and then we set up the problem so that our mole-mole factors cancel and give us the answer that we want. So here's our example. Put it on hold. Go ahead and try this on your own. This is already balanced for you. And so let's see if you can calculate how many moles of iron are needed for the reaction of 12 moles of oxygen. Okay, so how many moles of iron are needed for the reaction of 12 moles of oxygen? Well, that means that what we're given is what? 12 moles of oxygen. And so what we need is what? Moles of iron. So to set that up, what I'm going to do is I start with what I have, 12 moles of oxygen. And I know that whatever I do, I'm going to have moles of oxygen down here, aren't I? Because that's how my conversion works. So what is the molar ratio between oxygen and iron? Well, for every 3 moles of oxygen, I need 4 moles of iron. Yes? Okay, and so then that gives me, and you can cross multiply if you're good at algebra, or you can just say everything on the top divided by everything on the bottom. So that's 48, and of course moles cancel. That's 48 divided by 3, and I believe that is 16. Is it? Let's check. 48 divided by 3, yes, 16. 16 what? Moles of iron. So our answer is C. And here is our lovely step-by-step showing us every little step, and yes, we get 16 moles of iron.